cool thing is, as gardeners, we've been doing a lot of these type of things that I'm going to talk about, and now a lot of the science is catching up to explain what we might have seen in our garden from some of these practices. When you look at agriculture, it's been quite different. We tend to focus more on the soil and use things like compost and other stuff on a large scale to do compost and things for agriculture. Generally speaking, there's been others that have focused on this for decades, really, but there comes with the plant beneficial microbes, or it can come with, and there's things that we can do to enhance those beneficial microbes. So as I continued studying about plants and looked into plant pathology and stuff, you find all these disease-causing microorganisms, but then you also find out that there's a whole bunch of good microorganisms, a lot more good ones than there are bad ones out there, and they do a lot of interesting things. The focus on especially large-scale agriculture, but even to a point in our home gardens, has been on chemistry for a long time. So nitrogen, phosphorus, potassium, those were the big three elements, fertilizers of consequence that we focused on, and it really was centered on what do I do to, feed the plant and kill the pest. How can I kill this problem, either insect or disease? The regenerative focus is on biology. So instead of looking at a problem and saying, okay, how do I kill this problem? It's, well, what's missing? What's the missing piece that is causing this whole system to be out of balance? So a lot of that focuses on the supporting microbiology of the plant, the whole plant system, I call it, because it really is amazing what plants are able to do. There's beneficial microbes that the plant is fostering and cultivating in the soil, but there's also beneficial microbes on the plant leaf surfaces, the upper part of the plant that we typically see. So thinking, okay, what kind of beneficials can I cultivate to help take care of this pest for me? Either beneficial insects or beneficial microbiology, or also what kind of nutrients are missing from the plant, and not just focusing on nitrogen, phosphorus, and potassium, when all the other microelements have very critical roles in the plant, in its functioning of metabolism and all sorts of things. And we typically, you might do a soil test and you kind of focus on the big three there. And we kind of think, well, there's all the micronutrients are there in the soil, so the plant will get them somehow. It's kind of a black box, but we know you can have instances where you have plenty of any one element in the soil, but the plant is deficient and it's not picking it up. And part of that is the microbiology. Also, there's a lot of good microbes that unlock or make it plant available, those different nutrients. So as you might continue on learning more about this on your own, don't overcompensate for this switch from chemistry to biology. The chemistry is still important. It's just that we can't focus solely on that. And because we're kind of behind the ball on learning about biology, we focus on that a lot. But really, they have to go together, and they're tied together in the real world. Next, I'm going to talk about a couple big kind of categories, and then we'll go over those kind of again in some more detail with something a little more actionable. First of all is water. Water is life. We have to have water in any living system. And so some things we want to look for, and these are things we can just go out in our garden and look with our eyeballs. We don't need any fancy kind of tests or equipment to do this. The key questions we're going to ask ourselves is, how much bare ground do I have? Literally bare soil. And also, do I have areas that are puddling for an extended period of time after I irrigate or after there's a rainfall event? Those are areas in those puddling areas that are indicating compaction layers. And you have to address those compaction layers kind of as a building block for everything else. As we do other practices, they will help loosen up the soil and improve the soil's structure and its permeability for water to infiltrate. But a lot of that compaction will take a long time, if ever, for natural processes to break that compaction up. So that's where we can come in and take a broad fork or some digging or just poking around in there and figuring out why you have areas of compaction. Coming back to the bare ground for a minute, that other picture there, you see if you have bare ground and you've had that for a prolonged time, really excessive tilling and stuff like that, that's going to break down the structure of the soil, and it's going to crust over when you have irrigation or rain. Like in that picture, it crusted over, the seeds germinating, and it can't push through that top little crusting layer, and that's actually like acting like a mini compaction layer there. So those are the type of problems we're looking out for. So next, after water, looking at the mineral and the soil structure and texture, but also mineral testing, what we typically think of as our soil tests. So something you can do without anything fancy or without spending money is get out there and get your hands dirty and dig a shovel full of soil, turn it over, and just observe, see what you can see. So when it comes to structure, that picture, that was one that I took. It was very interesting in this soil area there. I was taking out some sod and it was just blocky. That's how you saw as I dug with a shovel or a skid steer or a pick and opened the soil up. That's just naturally how it had been structured to that point. A lot of times on a sandy soil, even a silty or clay soil, we can have a structure. What we call that is a massive structure when it doesn't clump, it doesn't break apart like clumps of cake or prismatic clumps like you see in that picture with my hand. And that's kind of the low point of soil structure. We want to build up from there. If you have that, you got a ways to go, but it can be done, and it can be done in not a lot of growing seasons if you really focus on it. So our ideal, what we're trying to shoot for, is this picture in the bottom right hand side where we have a lot of organic matter in that soil. It looks like chocolate cake. It's crumbly, it holds together, but there's little pieces that break apart easily. It's easy for water to get in. We're getting oxygen exchange, all sorts of good stuff. So another part of the mineral cycle to make sure that nutrients are cycling the way they're supposed to is, do we have organic matter? So we like to put compost or mulch, leaves now heading into the fall, but when we put them on, do they break down? Do they sit there a long time all the way through the spring and hardly break down at all? That's an indication that we are not having nutrient cycling. We're having a lot of beneficial microbes that are not there. We have, not a fully staffed ecosystem of microbes to break that down. On the biology side, when we dig into the soil, do we find any earthworms? I recently moved houses, but when I first started my job here, I was right here in Rexburg in a new house. It was awful soil from the building construction in the development area, and really rocky, terrible ground. I put in the sprinkler system, started putting plants in that first year, and I didn't see a single earthworm the whole time I did any of that groundwork. That was spring and summer of 2020. We moved in just this summer, 2025, so about 5 years, and complete completely different. I was actually finding an earthworm almost every time I dug a hole to plant something. So we covered the ground, we had wood chips on. We didn't do any synthetic pesticides during this time. Very little fertilizing of with your kind of regular NPK type of fertilizer. Anyway, we're looking at earthworms as a canary in the coal mine, as an indicator of what the health of the soil is, both mineral and microbiology, because worms are actually feeding, they might be ingesting organic matter, but really they're ingesting that because they're eating the microbes that are decaying that organic matter. There's an interesting case study where they were looking at doing some micronutrient fertilizing in a field, but they also wanted to look at how earthworms would do compared to this. So they had to just kind of split the orchard rows. We had a mineral treatment over here, and that was designed to help improve the structure of the soil. And then they put earthworms over here on this other side. When they came back and were over here looking for the earthworms, they couldn't find any. Okay, well, let's go do our assessment over here where we improved the mineral components of the soil too. And lo and behold, they found the earthworms. So the earthworms had moved over there where they had improved the soil in a mineral sense, but that also helped open up the structure of the soil so it was more permeable to gas exchange, oxygen, and water also. So the earthworms are a great indicator there of soil biology and minerals too. Another biology check we can do is, do we have any beneficial insects? And I just wanted, there's a lot of that and a lot of them. I didn't want to focus on that, but I wanted to pull one out in particular that maybe you're not as familiar with. These are hoverflies. Looking at them, just like their name implies, they're going to be by your flowers and they're just hovering in the air. And then they move, kind of flitter down, do some stuff and come back and just hover over the flowers. When you look closer, like, oh, is that a wasp or a bee or something? Because they have these yellow and black markings, but they're actually a fly and very beneficial fly. So their larvae look like a small larva of ladybugs, if you're familiar with them, kind of an alligator lizard looking larva, but these ones on the hoverflies are a lot smaller and they're the more sandy cream colors. They're very, kind of insignificant to look at. You might miss them a lot. One picture on my hand, you can see one of the larvae, so you can see how tiny they are, but they are really voracious predators of aphids, just like our ladybug larvae. Some great plants that they tend to like are alyssum and thyme, petunia also. Fern bush is one of our natives. I've seen it a lot on my fern bush in my old yard. Don't have it anymore, but so if you're seeing a variety of beneficial insects, that's also a sign that things are going good. Okay, energy is the last of the big four systems that we need to pay attention to. And what it comes down to is, how much sunlight are we wasting? How much sunlight are we spilling on dead matter? So it's great to cover our soil with a mulch. It would be even better if we can, say in our vegetable garden area, if we can use a cover crop or some other plant that might be beneficial in some way or harvestable in some way that is growing in the cool weather, to maximize the amount of sunlight that we're capturing with a plant, because the plant is actually using a lot of its sugars from photosynthesis and releasing them in its root zone to cultivate beneficial microbes. So that's very cool, very interesting thing. And the more of that we can capture and feed the soil naturally, then the more our soil is going to improve. Another component of this that is important for us in the arid west is the sunlight is going to cause oxidation. And this is a newer discovery, realization, if you will. We know about oxidation and reduction reactions, say in our bodies or metabolism and health and different things, but it hasn't really been thought of in soil science. So given our low rainfall environment and our soils and high pH, we have soils that become oxidized. It's an oxidation reaction is like a fire. It's burning, it's using up energy. So we're losing energy out of the soil in kind of a physics sort of way, besides not having very much organic matter. So anyway, that gets into a little sciencey thing, but it's important for our context. So to sum up, we have 4 ecosystem processes, and I gave you some key indicators to look out for that you can use with your own eyes and hands. So how much energy do we have coming into our system? How much sunlight are we capturing? Do we have a good water cycle? Do we have puddling and ponding, and then the evaporation going off of that from our soil? Very important, because our beneficial microbes need water and moisture in the soil just like our plants do. So if we have periods of dry soil, that's going to negatively impact our soil biology that we're trying to build up. Our mineral cycle and cycling of nutrients, crop waste, plant material. You know, sometimes when I was doing landscape work before extension, people would complain about their bark mulch breaking down because they had to reapply it, and you know, they wanted to get dye, or you know, can we put something on there that will prevent it from breaking down so I don't have to keep doing that? Well, that's what we want to happen. We want that to break down and improve the soil. And then diversity. Usually our gardens are, you know, our ornamental gardens are full of diversity already, and it's easy for us to add that in on a small scale in our vegetable gardens as well. And especially if we have a small vegetable garden, I mean, everything's close together anyway, but adding a diversity of plants, and not just plant cultivars or plant genuses, but actually plant families. So, you know, all our solanaceous, tomato, potato, eggplant, peppers, that's one family. But you know, so you might like say, oh, that's pretty diverse. I got potatoes and tomatoes in here and this and that. Well, it's all in the same family, so it's actually really not pushing the envelope as far as diversity of things. On the water cycle, I'm actually going to talk about the soil for this section, because elements of calcium, magnesium, sodium, and potassium, those are 4 key elements, and their interaction with each other will cause a soil to be tight and hard, or to be more loose and let water infiltrate and let oxygen into the soil more too. Our plant roots need oxygen in order to function. We don't think about that because the soil doesn't have enough oxygen for us, but for the plant roots, they have to have that small amount of oxygen that is in there. Being efficient with our irrigation, we can use drip irrigation and soaker hoses, and we get that directly to the root zone. But something we have to watch out for is, you know, we use those systems to be very efficient, but we can also limit our plant by only keeping a very tight area of soil moist for that plant. And the plant roots can't grow into dry soil. You might find roots in dry soil when you're digging something up, or you know, transplanting, but those roots didn't start there in dry soil. When they grew into that soil, it was moist and it was wet. We have an advantage being more arid out here. We have less foliar diseases, and having a drip system and soaker system can contribute that way too. Harvesting our rain is with some rain barrels or a rain garden. using your downspout and creating a artificial swell there to collect and hold that water and slowly let it percolate into your garden are some great methods to use. Mulching. So I mentioned that it helps keep moisture in, and that is very beneficial for us, not just for our plants, but for maintaining active microbes in the soil. You maybe already have turned off your water system. Make sure you get things good and well watered in the garden before you turn it off, because some falls we get into really dry weather in the fall, and things that are going dormant, our deciduous plants that are going dormant, they're just fine. But our evergreens, especially our trees, they're not dormant yet, and they can get drought stressed in that time frame of the fall, before we have really cold temperatures in December and January, where they go more truly dormant. They can actually run into drought stress in that time. But also, we're doing that for the microbes to stay active. The mineral cycle, the really key concept here is this little box over there on the side, and that is that healthy plants will resist pests. We really, at least for me, for a long time, I mean, I was educated in this, and I kind of knew there was a little bit, but you never really thought about it as far as an immune system in a plant. But plants do have immune responses to diseases. So that comes into play here with the mineral cycle, and paying attention to all the nutrients, the micronutrients, because those are very important in these systems that help the plant fight diseases. So some things that we can do in our garden is minimize the tillage and the disturbance that we do. Really, I should say disturbance, because that can be physical disturbance, chemical disturbance that kind of turns the table and upsets the ecosystem, beneficial ecosystem that we're trying to create. So you can think of a forest floor situation there, where we have decaying matter and lots of beneficial microbes, especially the beneficial fungi, mycorrhizae. So these are fungi that form a partnership with plant roots, and that helps the plant pick up a lot more nutrients than they otherwise would, especially phosphorus. So if we over fertilize with phosphorus, we're going to disrupt this friendship and partnership that the fungi have with our plants. Also, tillage, mycorrhizae you can think of as a spider web in the soil. So you can imagine when you go through and till, what's happening with that spider web. It's totally getting destroyed. There are times where we do need to till, but on a whole, we've over tilled and overused this tillage tool to try and fix some problems. When we over till, we end up breaking down that soil structure, and the more we break it down, the more we need to till in order to loosen the soil up again. So we just get ourselves into a cycle there. Compost is so beneficial, and the magic of the compost comes from the microbes that are in that compost. So adding that has a lot of benefits. This is an important part where chemistry, things like pH or salts, still matter. They're still a real thing. So just because we compost doesn't mean it's a quality compost. You can take this a step further with a compost tea, or plant extracts, targeted mineral support. So doing at least a baseline soil test, a complete test, all the micronutrients, would be beneficial if you want to be serious about doing regenerative practices, because we can look at those micronutrients that might be deficient. And when it comes to micronutrients, it's a lot easier to get results by applying them foliarly onto our crop or our ornamental plants. The micronutrients, especially iron, there's such a complexity of chemistry going on in our soils that there's a lot of things that can tie up that iron and make it unavailable for the plants. So we can just skip that whole scenario by applying it on the foliage. that is a little bit of a Band-Aid situation, but you are going to get better, more noticeable results doing that than applying it to the soil. There's just a longer process of getting that to work in the soil. Just to give you an example of the impact that mycorrhizae can have. So this was a study where they looked at the plant roots and verified whether it was inoculated or not. So there on the left-hand side, we see a completely non-inoculated plant. So no mycorrhizae fungi there. And then one product here, a second product that they used here, you can see the expanded root volume and mass, just an amazing result and difference there. Plants don't start realizing a benefit to this partnership until they have 40% of their roots colonized. Before that point, the plant is actually investing into this relationship to make it work. They don't start getting a return on that investment until they have a 40% colonization. So it has to reach that critical mass. And a lot of studies, if you look for something and it's like, well, it kind of worked, this time it didn't work, this time it did, they usually don't go through all the effort of looking at how much of the roots were colonized after their study. And so if they didn't do that, you can't verify that they actually took hold of that treatment, that it actually worked, if you don't actually verify that the roots are colonized. And that's a technical and difficult process. That's why a lot of the studies don't actually do that. Biological diversity. So a mix of plant species, like I talked about, rotating plant families, also important. Different plant species and families interact with different sets of microbes and interact with the mineral component of the soil in different ways. And so we build a more resilient system as a whole when we have that diversity. That's why it's important. Attracting beneficial insects, things like dill and fennel, cosmos, marigolds, sweet alyssum, those are all great for our beneficial insects. In general, our beneficial insects eat the pest insects in the larval stage. That is, the beneficial insect in its larval stage is primarily what's eating our pests. But in order to keep the adults around, they are usually feeding on pollen and nectar. So fennel and dill, alyssum, these are things that are easy for those beneficial adults to access, and they don't have to compete against other insects usually as much on those plants. Encouraging our natural predators is we want to avoid broad spectrum pesticides. And that can be difficult even with organic or natural thing that you might use. For example, the house I just moved to, we have a large orchard. And this year I've noticed the previous owner hadn't sprayed anything synthetic for years and years. And every tree I went to as we were harvesting, I would see multiple ladybugs. So when it comes time for spring and spring pruning, I'm going to be paying attention to any ladybugs that might have been hiding out for the wintertime on the tree. I suspect that they'll probably move down to the ground and other places for the winter time, but that's a scenario where I might not use my dormant oil spray, because if I have my adult ladybugs in that area, I'm going to kill them. So that's one of those things you have to bear in mind, and sometimes you have to weigh those pros and cons depending on what is actually going on in your system. So cover crops are a great tool to use. You need to have a plan for why you're picking a particular cover crop, and also what you're going to do when you're done with that cover crop, how you're going to terminate it. Some of those can be cut down or just mowed down. There's also a new online tool. It's geared for farmers, but you can use it too. The Western Cover Crop Council. You can go to the website there. There's a tool there that is live now. You can select what you're trying to do and your climate and different things like that, and it'll spit out and say, okay, here's your top choices for that. The overall practices that we might be missing in our gardening situation here is nurturing the soil. We want to feed the soil so it can feed the plants, right? So the plant can get everything it needs. That's a long-term process, but some stopgap measures we can do are some of those foliar feeding, adding microbes, beneficial microbes. There's lots of different inoculants. A lot of the local nurseries have those that you can buy. You can buy them online. Try and look for a reputable company when you do that. But you can add a little bit of that every time you're planting, either annuals or perennials. So this diagram here is the soil health principles. This is what I've just talked about, but I tried to do it in a way. If you've seen this already, hopefully I gave you something new or a different perspective, but this is basically what I've gone over. First thing is to know our context or your particular context. This really is an individual based model of approaching plant cultivation and plant health. So knowing your context and your particular yard is very important. Minimize the disturbance, cover the soil, increase the diversity. The hardest thing in the garden situation is adding the animal component, but we can get some of that benefit by using manure, composted manure. Chickens, rabbits can fit into our yard and garden scenario pretty easily. A couple tips, you don't need to do everything at once. Focus on what you can do and manage at one time and pick those practices. If you're able to physically and you don't have a really large garden, using a broad fork in place of tilling. If your soil's to that point, you might be working with a really broken soil as far as those cycles that we talked about. So that might require a lot of organic matter input and tilling in that to get it to the point where it's just naturally nice and easy to work and you don't have to till. And enjoy the gardening.